Oh, me, I would say me.
All right, yeah.
So here we go back. So the problem was we want to talk about calculating these type of integrals. We consider two cases. One case is that the degree of the numerator is smaller than the degree of the denominator. We consider two special cases. The degree of the denominator is 1. The degree of the denominator is 2. But now we consider the degree is 3 or greater than 3. Okay? So it's a little bit tricky, and these questions could be extremely lengthy and very boring, okay? But of course, the good news is that in the exam, they just gave you questions that they want to test you if you know the theory, not very detailed calculations. So there is a theorem in mathematics that if I have any polynomial of degree, for example, greater than or equal to 3, and then of course I can always consider that the leading term is 1. The leading term is the coefficient of the highest exponent. For example, I don't want to consider these polynomials. The leading term here is 2, because then I can factor a 2 and make the leading term 1. So that's not a very big loss of generality, okay? So in that case, we have a theorem that this polynomial can be factorized into a product of first degree and second degree polynomials, for which the second degree polynomials doesn't have any real roots. So when I write it, it seems very strange, but it is not that hard. So it means that we can factorize any polynomial of degree greater than 3 to a bunch of first degree polynomials and a bunch of second degree polynomials. Oh, so let me change these letters alpha, and then let me write this beta 1 x plus gamma 1 up to x to power 2 beta. I chose this m, this might be n. Okay? So, but these second degree polynomials does not have real roots. It means that discriminants are negative. So there is a theorem that guarantees that every polynomial of degree greater than or equal to 3 can be factorized in this form. Okay? Sometimes to some powers, of course. So that is why sometimes you might say that is not true. Yes, you are right. But let me put the powers, then it becomes clear. So if I put, for example, here P1 up to Pm, and let me write here Q1 up to Qn. So don't worry about this form. It's a very simple thing. You know, for example, I don't know, if I give you Q of x to be x squared, so x to the power of 4 plus x to power 3 plus x squared. For example, this is a polynomial of degree 4. So I can factorize it as x to the power of 2, and then I have x squared plus x plus 1. Okay? And then if you calculate the discriminant of this, you will see it is negative, so I cannot factorize it more if I still want to work with real numbers. In this case, we want. So it means that there is one factor, x minus alpha. If you want to compare this one with this one, alpha 1 here is 0, so let me write it for you. And compare it with the general 4. You see how many of these terms I have? Only 1. Alpha 1 is 0. P1 is 2. And how many of these type of polynomials I have in this factorization? Only 1. Okay? And Q1 is 1. Beta 1 is 1. Gamma 1 is 1. So here P1 up to Pm, Q1 up to Qn are non-negative integers. If all of these are 0, it means my factorization is only involving first degree polynomials. If all of them are 0, then I will have only these types. But that's a very simple thing. So it means that any polynomial that I give you with degree greater than or equal to 3 can be factorized like this. Now, I don't say that factorization is simple, but you will not get questions that the factorizations are hard. The factorization at the level of high school is enough for you, okay? Is that clear? Okay. Now, I think the best way that I can start teaching you, I have written these things extensively in the notes if you want the theory, but let me start solving some problems for you. Okay, so for example, I want to calculate this integral. What is that? X squared plus 3x minus 4 dx. Let me call it y. You want to calculate y. Okay, so let us review everything briefly. Do you see that this question is relevant to this topic? It's a fraction, a polynomial divided by polynomial. The degree of the numerator is less than 1. Yes? Okay. By the way, this is very similar to the problem I erased. Do you remember? It was very similar to the problem. It was x divided by x squared plus x plus 1. Why do you think that the strategy is different from this strategy now? Because in principle, could I give this problem before the break to you, based on the information I gave you? The answer is no. Because, or can I? Because the polynomial that I gave you there, it was not factorizable. But this one is factorizable. Okay, so in principle, x squared, but that's a good question. I have to see what happens if I do it the other way. But for the time being, what I want to tell you is that the first thing you do is to write your fraction with the factorized denominator. Most of the time they give you the factorized form, but if it is not, they give it in a simple way that you can factorize it yourself. It was not possible to factorize this before because the discriminant of this is negative. But this one, can you factorize this in your head?
X plus 4 minus 1.
So I put one x here and one x there. I ask myself, what are two numbers whose sum is plus 3 and the product is minus 4? Can you guess those numbers?
4 minus 1.
Yeah, plus 4 minus 1. Okay? So now this was a second degree polynomial. I was able to factorize it. But now this is the method of partial fractions. What do? How many factors you see in the denominator? 2. You are supposed to split this one fraction into 2 fractions. Okay? In the denominator of one of them, you put the first one. In the denominator of the second one, you put the second one. But there is no guarantee that this equality works. You need to put some coefficients up there. For example, for this one, I put A. For this one, I put B. And I ask myself, how can I fine-tune A and B so that this holds? I am not claiming that this is always true. I want to fine-tune A and B so that this fraction, which is equal to this fraction, can be split into 2 fractions. That is called method of partial fractions. These are partial fractions of the original fraction. Is that clear? Okay. But there is another important point. These coefficients, these factors are either first degree or second degree. If they are first degree, you have to put a constant up there. If they are second degree, you have to put a first degree polynomial up there. I will give you examples so that you understand. But for the time being, this is the way we do. But now, my duty is to find A and B. It is not usually easy to guess. Okay? So we have to derive. How we derive that? Forget about this original one in the non-factorized form. Work with the factorized form. Get rid of all the denominators by multiplying both sides by the denominator of the left-hand side. So let me do it once in front of your eyes, but then we will do it in our heads. So I multiply the left-hand side by this, and I also multiply the right-hand side by the same thing, because I want to keep the equality. Yes, usually I suppress this step. I just do it in my head. Okay, but now if I multiply the left-hand side by this, what will happen? Both of them and both of them here are cancelled, and I am left with just one x. So I write it here, x. Okay, can you do it in your head on the right-hand side? There are 2 terms involved. You have to take this one, multiply it here. You have to take this one, multiply it here. But when you multiply this here, this x plus 4 cancel this one, this will survive, which will be multiplied into the numerator. So this becomes what? Ax minus 1. Do you agree? And then I multiply this here as well, but this time x minus 1 cancels that x minus 1. This survives, it will be multiplied into the numerator. Yes? Understandable? But then what you do, you open it up, or you can, I will teach you some tricks. Sometimes you can do it very fast. But the correct way to do it, you multiply it, you multiply that one as well. And then you arrange this, so the left-hand side is just this one. But here I have two terms involved with x. I factor x out, and I would write a plus b. And I have two terms without x. I put them together, 4b minus a. Yes? So I am just doing very simple algebra, high school algebra. Understandable? But now what happens? I want to fine-tune capital A, capital B, so that those choices forces the right-hand side to be equal to the left-hand side. So if this is going to be the case, you have x on the left, you want to have x on the right. So this forces me to make it equal to 1. And there is no constant term there, so I have to put this one equal to 0. If I do that, then the right-hand side becomes equal to the left-hand side. So this means that I want to solve a system of equations in which a plus b is equal to 1 and 4b minus a is equal to 0. Okay, so this is a very simple system to solve. For example, when I add them, a's are cancelled, 4b, 5b is 1, so b is 1/5. And for example, if b is 1/5, I put it here, a becomes 4/5. Okay? And then what I do, I go back here, or let me also include this. I go back here by those numbers. So this is my original fraction, x divided by x squared plus 3x minus 4, and I don't need to write this middle one, but a is 4/5, so it becomes 4/5, multiplied by 1 over x plus 4, and then b is 1/5, 1 over x plus x minus 1. Do you agree? So you open it up, write it as partial fractions, and then fine-tune a and b so that this equality indeed works, and then put them back and then integrate. Now instead of integrating this, I integrate these two simpler ones, and hopefully all of them are of one of those types that we already have. So this means that the integral, which I called I, is equal to integral of this one, which 4/5 goes out, 1 over x plus 4 dx, and then plus 1/5 integral of 1 over x minus 1 dx. Do you agree? But I have erased the formulas. If you check your notes, this is one of those cases we learned before. This is also one of those cases we learned before. So I have it in my memory. So this becomes 4/5. This becomes ln of absolute value of x plus 4. And then this becomes 1/5 ln of absolute value of x minus 1. And then plus a constant. Is that right? So this is the general idea of partial fractions. If you have a more complicated fraction, you partition, you decompose your fraction into several partial fractions with the hope that integrating of those partial fractions are simpler than the original. Is that right? Mm-hmm. Understandable? Okay. And then, sorry, you with the cap, hello. So do you remember now your question? So this was the method. Do you remember you asked the question about like, how do I know this? Do you remember I wrote this like that?
Yes.
Yes? And that is the method. So if you don't know how to guess, this is x minus a, x plus a. And then what happens? It becomes a over x plus a plus b over x minus a. And then fine-tune a and b exactly in this way. So that was the general idea. But it was so simple to guess. Whenever you can guess, by the way, guess. If it is hard, because you know that this method becomes very tedious, especially if this becomes a little bit more complicated. That is why they don't give very, very complicated ones there. Okay, any questions here? So if these polynomials are of first degree without any powers, the idea is to put constants there. Yes? So now we go to another example. So this is another example. Let me write this one for you. So integral, so let me call this one J. Integral of x plus 1 divided by x to power 3 minus x squared dx. Yes? Can you still see that this is the same topic? I have a polynomial over polynomial. The degree of the numerator is smaller than the degree of the denominator. But remember, when I go home, I will check if this method of complete square works here or not. Okay? That's also good to see. Okay, tell me what I'm supposed to do. Yes? Denominator. So you start with your fraction. And then what do? You factor out as much as you can in the denominator. So this is extremely simple. So I can just factor x squared out. And I get this. But now, this is the second. So I am giving 3 different examples to highlight everything. Because we don't have time to go through this. By the way, you might even at most get 1 question in the exam. Okay. So can you tell me, this is what I want to do. How many fractions you expect? How many partial fractions you expect now? Here, I had 2 factors. How many partial fractions I had? I had also 2. So somehow you are right, because x squared is 1 factor, x minus 1 is also 1 factor. But x squared is of the type x minus alpha 1 to some power. Okay? So this can be viewed as x times x minus 1. So in principle, I have 3 factors involved. But this is the trick you have to learn. So what is your first guess? What do you think I should write? I mean, if you really want to see why it does not work, your guess, hopefully it works. But if not, you have to go home and see that why it doesn't work. Okay, yes?
ax plus b divided by x squared.
Ax plus b divided by x squared.
And then plus c divided by x minus 1.
Yeah. For this one, yes, you are right.
Yeah,
That is, as I told you, because this becomes what?
1 less than the denominator.
1 less than the denominator. But this is usually not the way people write. Okay? They actually do it like this. Okay? And then this one and that one are gone. And this one and this one are left. Okay? But what you said is good, because it is the same rule. And that's very good. So this is why I don't write it like this, because if you see the book starts by writing this. But that was very good that you told me, because there is no confusion now. We are just going to this rule. If the denominator is degree 1, the numerator is a constant. If it's degree 2, it will be what? Degree 1. So if you see x squared, right from the beginning, write a over 1x and then plus b over x squared. And then a c over x minus 1. Yes? But of course, as your friend said, that's completely true if you want to write it like that. And then what is the next step? The next step of all of them is the same. Get rid of all the denominators by multiplying it by the common factor. So you just multiply everything by this denominator, but do it in your head. If I multiply the left-hand side by this denominator, what is left? X plus 1. Take this one, multiply it by the first one. 1x cancel 1x. 1x and x minus 1 are surviving, and then I multiply them here. If you have trouble with algebra, please ask me. And again, compare this one with that one. This x squared cancel x squared totally. X minus 1 is left, which I multiply in the numerator. Yes? And then when I multiply this denominator, only denominator. If you want, you can write one. I'm doing something similar here. Okay? And if you multiply that, it becomes plus c x squared.
Babak,
Yes.
can you explain me how we came from x, the denominator x squared times x minus 1 to then like an extra x there? We have x
Here?
squared. Yeah.
No,
yeah.
no, it was. So I told you that when you want to split the fractions, there are two possibilities according to this theorem.
Okay.
Either a second degree polynomial will survive or a first degree polynomial will survive. The rule is that if that's a first degree polynomial, in the numerator put a constant. It's a second degree polynomial, in the numerator put a first degree polynomial.
Okay.
Yes? So here, in principle, if I want to follow my own rule, I have two factors. So I split it into two factors essentially. One x squared here, the other one x minus 1 here. This one is first degree, so I put a constant up there. This is a second degree, I put a first degree. But first degree is ax plus b.
Okay. So.
Yes? This is correct. But usually it is easier to write it in that way. Write ax over x squared, and then b over x squared. But this x and that x are cancelled. This is why instead of writing like this, I wrote like that.
Okay.
Yes?
I get it. Thank you very much.
Well, but then the next step is to multiply. Do you have any problems with this algebra now? Algebra is okay?
No.
Okay, now, so I want you to do it in correct way, but you can cheat a little bit. For example, if I want to find C, what do you think I would do to find it very fast?
Make x equal to 0.
No, to put it 1. Because if I put x equals to 1, this is gone. This is also gone. And this becomes C. And then I put 1, so C is 2. Do you see that? For example, if I want to find another one. So by our correct guess is that C should be 2. Because this is going to be valid for every possible choice of x, including x equals to 1. Why did I choose 1 out of the blue? Because I will get rid of these other variables, and one variable will survive. So now tell me, is there any other one that I can use? I can use the same trick to find?
0 to find b.
Yes, if I put 0, this is gone. This is also gone. Minus b is left. Yes? And then if I put 0 here, what is that? 1. So minus b is equal to 1. So b becomes what? Minus 1. But in all the solutions of the examiners, none of them has done it like this. So I want you to learn how to do it properly. And properly means open it up and equate them and then solve the system of equation. But at least this is good to check if your solution is correct. Okay? So if I write it as like this, it becomes x plus, and this is simple algebra. I open it up. And I start collecting the same terms. So here I have x squared. I factor x squared out. Here I have two x's. So I would write b minus a by factoring x out. And then finally I have one constant term at the end. Yes?
Then we substitute by the values that you found?
No, that's the trick. In the exam, I don't know. None of the examiners has solved this problem by this trick.
Okay.
So they are solving it in that way. So don't do that in the exam. Okay? Yeah, but if you can justify exactly, no one can criticize you. But now can you tell me what will be my system now? What do you think will happen for a plus c? 0, because there is no x squared there. So I have to force it to be 0. And then what should be b minus a now? 1, because there is only one x. And what should be minus b? What should be minus b? 1. So from here, I get immediately b equals to minus 1, which matches with my cheating guess. And if b is minus 1, I put it here. B is minus 1, I move it here, 2, so a becomes minus 2.
That's much harder.
And then if I put minus 2 here, c becomes 2. Yes? So our guess was correct for both of them. But of course, I just want to tell you that the third one you cannot find, you can find it by doing what? After you found c and you found b, you can put any other number, but because you already have c and b, you can also find a.
Yeah.
Yes? But don't do it like this. Okay, but now let us do it. What will be the answer? What I'm supposed to do, I will put these numbers back here. So my J integral will be equal to, so integral of this one is 3 integrals now. Integral of the first one, in which a is -2, so I bring -2 out. Integral of 1 over x dx. Can you tell me the next one? I want to see if you're following it. Can you give me the next one? What is the next one? B over?
X squared.
B over x squared. What is B?
-1.
-1. So what should I write? Minus
Integral
1 or integral
1 over x squared.
1 over x squared dx. Very good. And then the last one? The last one, C is 2. Integral. Is that okay?
Yeah.
But all of these are doable. So what is the answer to this one? ln, absolute value. This one is also famous. If you don't remember it, bring it up. X to power -2, add 1 unit, 1 unit. But I have it in my memory, so it becomes 1 over x. This you really don't need to remember. You bring it up, x to power -2. X to power r is x to power r plus 1 divided by r plus 1. That's the same story.
Yeah, minus thing.
But this one?
Minus.
No, this will have a minus sign in it. It makes it positive. And then this one is, today we learned about this today. Yes? 0 degree, first degree. So it is ln.
You can use the U substitution in from here, right?
Yes. Because that was the reason I derived the formula rather than telling you memorize. Okay, so if you want, you can simplify it a little bit. For example, I can factor these two, and this becomes this ln minus that ln. I can write it as division. This is your answer. Yes? Understandable? Now one more, because we have to do it, otherwise you will not learn completely what we're supposed to do. The next one and the last one of this type, integral of x plus 1 divided by x to power 4 plus 4x squared dx. So let me call this integral k. I want to find k. Yes, so what should we do now? As usual, I would write x plus 1 divided by x to power 4 plus 4x squared. But how should I continue? The first step is to factorize the denominator. Sometimes they already give you in the factorized form. Yes? But be careful. If it is x squared minus 4, you shouldn't stop there. This is not correct. Don't stop there and say that, okay, because x squared minus 4 is second degree, I put the first degree up there. If it is not factorizable, then you can stop. Is it factorizable more?
Yeah.
No, x squared plus 4 can be only factorized in the realm of complex numbers. So if I want to factorize it, it becomes x minus 2i, x plus 2i. In this topic, you are not allowed to use complex numbers. So when I say, is it factorizable? I mean, is it factorizable on the realm of real numbers? The answer is no. So this is the end. And if it is the end, now, how many partial fractions you expect? 1 for the last one, which I write here. But according to the experience from x squared there, either you can write it like this, which is not usually written in the books. They prefer to write it as, can you tell me? Two terms. One term with x, the other one with x squared. Okay? And now let us do that. This one I will write a. This one, be careful. Don't say this is x squared, put another first degree here. Either use that idea or do it like in the book. So I write b. But what about this one?
See?
C is not correct. Because this is second, I have to write the first degree. So what is the first degree? Cx plus d. So you see that even for this simple fraction, you have to do a lot of calculations. Yes?
What happens in the case where, let's say, instead of x squared, you have x minus 1 whole squared? Do we still
Don't you have to factorize? x squared, so it will be x squared minus 1 to power 2. So then you have to write x minus 1 to power 2, x plus 1 to power 2.
Yes.
Then you have 2 for this one, 2 for this one. Okay. So you should write a over x minus 1 plus b over x minus 1 to power 2 plus c over x plus 1 plus d over x plus 1 to power 2. Something like that.
So the power of the factor is how many
Yes.
fractions?
Yes.
Okay.
And I have written a very different examples with horrible fractions, not because you want to do it. I just want you to learn how to factorize.
Yeah.
And if you see those examples, you will learn. I hope that you also learned it. Okay, but now when you write it, then everything becomes clear. So can you do the next step? The next step is to get rid of all denominators by multiplying it here. So let us do it in our head. The first one becomes x plus 1. The right side, remember, I am multiplying the whole combination into all of them. So the first one becomes what? Becomes ax times x squared plus 4. Because 1x cancel 1x. And when I multiply here, x squared and x squared are gone. This survives. I multiply it there, so it becomes b times x squared plus 4. And the next one will be what? This one and that one are cancelled. X squared is left. I multiply it there. Yes? But now the trick is there. But here, when you have second degree polynomials involved, that cheating trick is a little bit hard. I mean, you can of course do it again, but let us do it properly. So I copy and paste the left side. I open it up. I multiply everything. So if I'm making mistake, please let me know. A to power ax cubed 4ax. Am I right? I am multiplying this in. Then bx squared. It's very stressful during the exam if you want to do this. Please double check before going forward. Because if you mess at the end, it is very hard to fix it. So let us double check. Ax cubed plus 4ax, that's correct. Bx squared plus 4b, that's correct. Yes. And then organize it. Organize means you can copy paste. Here I have this one and that one of the same type. I factor the cubic term. And then
ax plus
this,
c.
what?
It's ax plus c.
Ah, very good, very good. Thank you, thank you. And then this one,
and
b plus d. And I write x squared. X is alone. And 4b is also alone. Did I consider everything? 2, 2, 2, 6. 1, 2, 3, 4, 5, 6. Yes. Okay. And then what should I do? This one should be what? 0. There is no cubic term. B plus D should also be 0. There is no second degree term. But what should be 4a? 4a is the coefficient of x. The coefficient of x is 1. And then 4b should also be 1. So the systems are not that hard. And that is more or less at the level of exam question. So they don't go beyond that, okay? So here, but you can see my videos. I am solving the problems from the book. They are very, very long sometimes. So here, a becomes 1 over 4. Here, b becomes 1 over 4. And then you put them back here. So what will be c for me? C is negative a. So c is minus 1 over 4. And then what will be d?
Minus 1 over 4.
Minus 1 over 4 again. You agree? Okay, put them back. Okay, let us save a little bit of time. So k, how many integrals will be there? 1, 2, and 3. Okay? The first one, a is 1 over 4. So I would write 1 over 4 integral of 1 over x dx. A is 1 over 4 and the function is 1 over x. The second one, b, is 1 over 4 again, but the function is 1 over x squared. Yes? And the last one, both c and d are both negative 1 over 4. So I factor negative 1 over 4 out. So can you do it in your head? So it becomes minus 1 over 4. Then I am left with an integral. The denominator is x squared plus 4. What is the numerator? It was minus 1 over 4, minus 1 over 4. I factored minus 4 over 1 over 4 out. What is left here?
X plus 1.
X plus 1. Yes? And I don't want to continue because now all of them are doable, yes? This is just ln. This is the same function we did here. But is this familiar now? What should I do there?
Split.
A split. Where is my chalk? Here. So I have to split it. So this itself becomes integral of x over x squared plus 4 dx plus integral of 1 over x squared plus 4 dx. Do you remember? Both of them are formulas. This is arctangent formula, and this is 1 over 2 ln formula. So everything is done. Yes, please.
How do we know that 4a is 1 and 4b is 1?
What? Yes, here I'm comparing them. A polynomial is supposed to be equal to this polynomial for every possible x. So this means the coefficient of the cubic term and the coefficient of the cubic term should be the same. But there is no cubic term here. In other words, the coefficient of the cubic term is 0. So this means a plus c is 0.
What I mean is that I see two constant terms and
Here?
oh, okay. No, I just missed something.
Okay, no worries.
I don't
No worries. Any questions? Okay, now what is your question? I'm testing your memory. You should have a question at this point.
In high school, we normally say it's going to be on the exam.
No, that's
So-
you cannot ask me because I'm not the
Yeah,
examiner.
exactly. So we don't.
Yes. So now, what you should have a question. You remember, this is just one root. What was the other root?
And what if the degree of the numerator
Is bigger. So all what we talked was about the degree of the numerator is smaller than the degree of the denominator. But the good news is that there is only one more step, so don't worry about that. Okay? So, and then so this what happens?
Please,
Now, do you
please just
remember-
say it's like, it's like this simple.
Yeah.
Like this.
So, yeah, I mean, it is not that
This is the
hard. I
hard
mean,
way.
It is.
So B. So the option A was degree. So option B
Please tell
is
me
degree
that
of
Henry was already.
degree of px is greater than or equal to degree of qx. There was some exam questions of this type. Yes.
But isn't that fairly straightforward? Because you just have to do a polynomial division.
Very good. So I will write it for you. So long polynomial division. So remember, this is the trick. Yes? And I want to give you one more example, and this is completely done now. So integral of x cubed plus x squared plus 2x plus 1 divided by x squared plus 1 dx. So let me clean some boards. Make it ready. Okay, so this one, first of all, do you understand this is related to today's lesson? Because that's a fraction, the numerator is a polynomial, and the denominator is also a polynomial. But it is not one of these things we discussed, because the degree of the numerator is 3, the degree of the denominator is 2, so the degree of the numerator is bigger. And then I have written you the code phrase, long polynomial division, which if you remember we didn't have time to go through. I was trying to do it in the first lesson, but now I can teach you here now. So there are different ways. I am used to the Swedish way of writing and Persian one. So I will not use the Persian one, I will not use the American one. The American one is written in the book. So in the Swedish system, if you want to divide this as a polynomial, they draw it something like this. Okay? And then they write this expression. And then you write this one here. Okay? And then you write the coefficients up there.
Oh yeah,
So I mean, this is called long division.
we learned that on basic math, but
Yeah, that's basic math actually. So, what I want to say is, first of all, make sure if you want to do this, you have to arrange this from the highest degree to the lowest. Usually they don't tamper with this one, they give you a straightforward. But be careful. This should be ordered from the highest exponent to the lowest. This should also be ordered from the highest exponent to the lowest. If it is not, arrange it yourself. And now what you need to do, you need to learn one algorithm. If you do it once, because that is algorithm, it's an algorithm, you have to do it over and over. That's the same thing. What is the first thing you do? You don't care about all the details. You pick up the first term, and you pick up the first term. You divide. That is very simple. You can do it even in your head. X to the power 3 divided by x to the power 2. What's the answer? It's x. And then you put that x up there. Okay? And then you multiply this x into every one of them. All of them. And then write them here with the opposite sign. Or you can write it with the same sign and subtract. But from my experience is that if you put the minus sign first, add is easier than subtract. That's up to you. So what I do, I multiply x by x squared. What is the answer? X cubed. I write it here, but with opposite sign. And then I multiply it by the next one. X times 1 is plus x. I don't write plus x, I write minus x. And then I draw a horizontal line, and I add this one to that one. Some books, they don't put this minus sign, and they say subtract them. Then you have to take care of all minus signs. Okay, that's up to you. When I add this polynomial to this polynomial, definitely this one cancel that one. This will not be able to add here, this will be added here.
Yeah.
But I have to bring the highest power first, because I want to keep the order. Minus x plus 2x is x
Plus
and plus x, and then I have plus 1 I bring down. If you learn this one, you are done, because you have to repeat this process.
Yeah.
So it means that now I take this one and multiply it by that one. So what will be the answer? X squared divided by x squared is plus 1. And then you multiply plus 1 here with the opposite sign. So it becomes minus x squared minus 1. And then you add them up. When you add them, this is gone. This is also gone. And then what is left? X. Here the algorithm stops. Why? Because the degree of what is left, which is called the remainder, is 1. The degree of this, which is called the divisor, is more than 1. Whenever this happens, you will stop. So you will stop when this becomes 0, sometimes it becomes 0, or it becomes something whose degree is strictly less than the degree of the divisor. When you do that, it stops. But how do you think this will help? This will help because always this is the case. If you want, I can write it here for you. If you have polynomial px and you use this divided by q of x using long division, there are some things you do here, unfortunately. Okay, so then there are something you calculate here, and then you reach to a remainder. So let me call it Rx, and you get a polynomial up there. So if you don't mind, let me, I don't know, call it A of x. And then this one multiplied by that one plus the remainder should be this polynomial. So P of x becomes 8x times Q of x plus the remainder. Okay? And now, what is the degree, how the degree of R and degree of Q are related? According to what I told you, you do not stop until the degree of R is less than degree of Q. Yes?
Shouldn't be P of x equals A of x plus R of x over Q of x?
No, for example, I don't know, if you divide 20 by 7, so what will be the quotient? It will be 2 times, and then the remainder will be 6. So if you multiply this by that and add it to this one, you get 20. That's the same logic here. Yes? Okay. So, but now the point is that here, go here and divide everything by qx. So P of x divided by Q of x is equal to, I divide this by Q of x, I get A of x. I divide this by Q of x, I get R of x divided by Q of x. Yes?
That's what I
Yes.
was thinking.
Yeah.
This is probably what you were thinking.
Yeah.
Yes? Okay. But now, what is my integral? My integral was this one. So my integral is splits into two integrals. Yes? But now, you don't have any problems here, hopefully, because this is not a fraction anymore. And this is one of those fractions we studied extensively here because the degree of the numerator is now less than the degree of the denominator. So it means that if the degree of the numerator is more, by just doing one long division and doing this trick of division, you will reduce your problem to a problem that you already know how to solve. Is that right? So here, can you tell me how should I solve that integral up there now? So what I would write, I would write that x to power 3 plus x squared plus 2x plus 1 divided by x squared plus 1 is equal to ax. What is my ax? The one I got on top is x plus 1 plus the remainder. What was my remainder? It was x divided by x squared plus 1. Yes? And now it is solved, yes? Because now if I calculate the integral, so integral of this expression is equal to the integral of this one, and that one. All of them are doable. This is x squared over 2, this is x, and this is what we just learned today. This is ln, 1 over 2 ln of this expression. So this is x squared over 2 plus x plus 1 over 2 ln of x squared plus 1 and then plus the constant c. So more or less this is a very fast way of teaching the partial fraction method, and this is the last one. There are other methods described in the book, for example trigonometric substitutions and things like that. I have seen that they have given you in the exam. Might be that's a good thing to solve one of the exam problems, okay? Because there is no time that I can go forward to a new lesson. So there was a question like this in the exam. So you are supposed to find this integral. Okay, systematically you don't study them. For me, I know it's a trigonometric substitution. But because you don't study these kinds of integrals systematically in this course, they have already given you a hint how to do the substitution. So they have written, do this. For example, take. So this was given in the problem. Solve this integral. I don't remember. Might be they ask you found the primitive function or whatever. Solve this integral using this substitution. Yes. So in principle, I am introducing you because usually, if you want, let me write it u so that you are not confused. This is a little bit strange, you know, because u substitution means that I write u equals to something. Okay, but in the exam they have provided this for you. Okay, but you need to find u yourself. But there is a subtlety there that I want you to understand that. So can you tell me if I just want to naively, because you know that if I do this, I know what to do with x. The problem has told me. So let me do that. By the way, it's simpler than that. Okay, tell me what to do. Yes, this integral is given. This hint is also given. You're supposed to do it.
Sorry, the hint was what?
The hint is that use the substitution x equals to 2 sine u.
When you substitute directly into x, you then get 1 minus 4 sine squared by 4.
So you mean that I put it here?
Yeah.
Yes, then let us do that. You are right. So, but I also need something else because I have to get rid of all variables. So, what is dx? Dx is 2 cosine u du. Yes? So I don't have any problems here, and as I told you, so I put it here. So this becomes integral of 1 minus 1 over 4 multiplied by x squared, but they have told us what to do. X squared becomes 4 sine u squared, and instead of dx, I am not allowed to keep dx because I have to unify all the variables into one name. So I have to do it. So this becomes 2 cosine u du. Yes? And now I want to continue. This 4 and that 4 are cancelled. So this becomes integral. Let me do it step by step for you because there is one more subtlety in the problem. And do you mind if I put 2 out because that's a factor? And then you have to remember something from trigonometry. 1 minus this one is not cosine. Be careful. Of course, in this case, if you just write cosine, it turns out to be the correct one. But it is absolute value of cosine. Yes? Because 1 minus sine u squared is cosine u squared. That is correct. So if I write it down, so it becomes 2 integral of the square root of cosine u squared, as you said, multiplied by cosine u du. But you have to explain it in the exam because this is the correct way of writing. Absolute value. You have to put absolute value. Do you remember? I told you square root of 2n, an even number, box to 2n, is not box, is absolute value of box. So this becomes absolute value of u times cosine of u du. And of course, there is no way I can do it in this form because I have to get rid of absolute value. But how can I get rid of absolute value? As I told you, the correct answer is without absolute value, but you have to justify it in the exam. Why do you think I can remove absolute value from here? I have to convince you that cosine u in this case has to be positive. How can I justify that? When they ask me to calculate this integral, it means that this function is defined. Otherwise, if this function is not defined, I cannot even do the integral. So it means that 1 minus x squared over 4 should be non-negative. Do you agree?
Yes.
So this means that x squared over 4 should be less than or equal to 1. It means x squared should be less than 4. And this means what? It means that x is somewhere between minus 2 and 2. Yes? X is between minus 2 and 2. So now, what is sine u?
Sine is between minus 1 and 1.
So I want to convince you that u is either in the first or in the fourth quadrant, which cosine is positive. Is it? So if I divide, yeah, it might be that the examiner didn't even think about it himself.
Yeah, because it then restricted to minus 1 and 1, and you cannot know if it's...
Maybe he gave a domain.
Yeah, they have to give a domain. Because the correct one, if I wanted to start with that one, so here I am right, yes? X is between this one, so x over 2 is between minus... There is no guarantee, by the way. So x over 2 is between minus 1 and 1, so I cannot put any limitation. Yes. Okay, in that case it becomes harder because then you have to discuss. You have to discuss yourself that if it is between 0 and 1, you take the positive one, and if it is between minus 1 and 0, you will take the negative one. And then you will get 2 answers plus or minus at the end. So it means that you cannot skip any one of them. I have to check the question in the exam. Okay? But then, anyway, let us forget about that momentarily. It becomes either plus or minus for the time being. Let me think about it, okay? And then this becomes integral of cosine u squared du. Yes? But do you remember, another thing you need to remember for calculating these? Yes? There's the double angle formula. So it is 1 over 2, 1 plus cosine 2u. And then of course these 2 and that 2 are cancelled, so it becomes plus or minus. Plus or minus, then the integral becomes u, and then 1 over 2 sine 2u. So you see, there is no way we can skip. But this is not acceptable, I am sure. You have to discuss that if x is between 0 and 2, I keep the positive one. No, we have to discuss very carefully about that. So I will think about it because there is no time. I'm a little bit stressed. But one thing I want to mention, this is not acceptable because I have to go back to the original variable. Okay? This is a little bit subtle because I don't have sine 2u, you have to go back to x. Because if you stop here, that's not okay because you are writing everything in terms of u. Okay, because we don't have time, and I don't know if there is any lesson coming in after this, so we have to wrap it up. So we go home and think together, okay? This one, we want to go back. This is easy, because when I divide, u becomes arc sine of x over 2. So I found u in terms of x. But what about sine 2u? You need to remember the formula. So it is 2 sine u, which is x over 2, times cosine u. So from sine you can find cosine. Then everything will be written in terms of x. Is that more or less understandable?
Yes.
Yes. But the only thing that is left for us to understand is this plus or minus. I think if you discuss, this plus or minus eventually will actually cancel out. Okay? This is my, if I remember it correctly. But we have to do it. Okay? Any questions? Okay, thank you. See you tomorrow.